In the last video, I showed you how to create a small Spring Boot application consuming the Dapr State Store APIs. You can read about this in this blog post. I think that the introduction was pretty simple and very focused on Spring Boot. So what I wanted to do in this second video is to deploy the same application that I've created using Spring Boot and test containers into a Kubernetes cluster with Dapr installed, right? Like this is how a real environment will look like. So I wanted to do this locally using Kine, a Kubernetes local cluster running on my machine, just to demonstrate the steps and to see how many changes do we need to make into the application for this application to run in a real environment. So let's get into it. I will be showing all the steps here, but I will be also sharing a blog post with all the steps if you want to reproduce them on your local environment. The main idea here is to show how to take the application that we already have and then how to deploy that into a Kubernetes cluster, all the configurations, all the steps that you need to execute in order to achieve that. The application will be doing exactly the same using the Dapr State Store APIs, but instead of using test containers and all the auto configuration happening in Spring Boot, it will use a real Dapr installation inside the cluster. So let's do it. So the first thing that I wanted to show that it's something that I haven't shown in the previous video, I think that I just briefly showed it, is that we have our customer catalog application, and by running nvn spring boot test run, I can just run this application in local development mode. I think that I've showed this, and basically I show that my application is starting correctly in port 8080, and it's also starting the Dapr sidecar right beside the application, so the application can use the Dapr APIs. What I didn't show is that I can use curl or HTTP in order to send requests to the application, and for that I added this customer JSON file here, which is basically a very simple customer definition. So what I can do is I can do HTTP, that's HTTP, and then 8080, and I can send a post request to this customer JSON file. Right, and if the service is working, this will register a new customer into the Dapr APIs using the State Store APIs, and we can see that the request was successful. We get a 200 back, but also we can also query the result here, so we can get the customer by ID, customer ID. In this case, it's a simple ID 123. And that's going to fail because it has an expression, so I just need to wrap it in quotes. And you can see that the customer was stored correctly, right? So by using this installation of Dapr using test containers, we have a fully functioning Dapr APIs that we can use. But again, this is running locally outside of any Kubernetes clusters and just using Spring Boot, all the capabilities provided by Spring Boot plus the Dapr and test containers integration. So far, so good. As a Spring developer, you can build, test, and even run your applications locally without running any Kubernetes clusters. But then when application delivery teams want to run this into a real cluster, well, then we will need to have Dapr installed in there. The whole idea here is that I will be creating a new Kine cluster using Kubernetes Kine, which is Kubernetes in Docker. So the only thing that I need to have running in my machine is Docker. And I will create a Kine cluster using Kine create cluster, and that's basically going to provision a new Kubernetes cluster in my local machine. This Kubernetes cluster is a very simple cluster. It's using version 1.27.3, which is pretty new, and the same steps will apply for a cloud provider cluster, right? Like if you have a cluster on GKE, well, you use that cluster instead of creating a cluster like this. So the next step that I wanted to execute is basically I want to install Dapr inside this cluster. So whenever I deploy my application, Dapr, the control plane of Dapr, will do the things that it needs to do in order to connect the State Store APIs that the application is using with the real State Store implementation. So let's do that. I have here a command, so I don't need to type it. And you can find these steps into the official documentation. I'm installing Dapr, the Dapr control plane 1.12. into my Kubernetes cluster by using Helm, right? So you need Helm for this, and this is kind of like the line that will install Dapr into your cluster. This can take a while because it will wait for all the components to be bootstrapped, but usually it takes a couple of minutes until all the containers gets downloaded and they are ready for the cluster to be used. So you can see Dapr is now installed. If we list the namespaces, you will see that there is a Dapr system namespace with the Dapr control plane components running. So now that we have Dapr installed, the next step that we want to do is we want to provide an implementation for our state store APIs. We can use different implementations. You can check out the Dapr documentation to see all the available implementations for the state store component. In this case, we will use Redis because we can easily create a new instance of the Redis database in our Kubernetes cluster by using, again, Helm. So I will copy another line here, which is basically installing a Redis instance into our cluster. We are going to use version 6.2 and the architecture standalone, so we don't use too many resources in our local computer. In this case, we're not waiting for Redis to be ready, but you can see here that there is a bunch of information about that instance. This is where the instance is going to be located. That's the URL of the service that we need to point our application to use. In this case, we are going to point Dapr to use that URL. And this is where you can get the secret that was created for connecting to the Redis instance. In this case, automatically generated password is created inside a secret inside Kubernetes. So now we have our environment ready. We have a Kubernetes cluster with Dapr installed and with Redis that we're going to use as the implementation for our state store component. So that's the last thing that we need to do in our cluster. We need to create a new Dapr state store component that will link our state store APIs being consumed by our application to this specific instance of Redis. You can imagine that you might have different data stores, different key value stores, and you want to make references from your applications to different state stores. And for that, we configure this Dapr component using a YAML file that we can look into the Kubernetes directory. So if I go to Kubernetes directory, you will find a couple of YAML files. And the one that I want to show you now is the state store one. So the state store component here, it's a very simple YAML definition file that defines a new Dapr component, in this case, state store using Redis as the implementation. So you can see here, we are using the details of the instance that we just created. That's the URL for the service that was shown before. And also we are using the Redis secret that was created with a key that contains the password to connect to that instance. So I will just apply this state store file, and there we go. We just done everything that we need to do in our cluster to configure not only the cluster, but also have a Dapr installation inside it. And also we have a Dapr state store component using Redis as the backing implementation. We install also a Redis instance that we are connecting to via Dapr in this case. So the application code doesn't need to know anything about the Redis instance itself, or even that it's Redis that we are using to store our key values that we're going to be creating with our application, our customers in this case. So the next thing that I wanted to do is I want to go back to the application, right? Because now we have the cluster ready, the environment is ready, but now we can go to the application to make sure that we have all the pieces to make sure that this application can run inside the cluster. So I'm switching back here to my customer catalog project. Remember, it's a Spring Boot project. And the first thing that I need to do is basically I need to containerize this application. Luckily for us, Spring Boot provides us that functionality using build packs. So we can run npm Spring Boot build image to basically containerize this application. This might take a while as well. It's going to run all the tests first, of course. After all the tests runs correctly, it will try to generate an image using build packs. In this case, you can see that it's using Paketo build packs to basically build a new image using the Java version 21. And this procedure will finish with a container image that we will have locally in our local Docker installation that we can then decide if we want to load into our kind cluster, so the cluster can use that image that is generated here, or if we push it to Docker Hub so other people can use it as well. So as you can see here, it took us like 35 seconds to generate the image after downloading all the things, all the tools that we need to do that. And that's kind of like the image location or the image kind of like name, fully qualified name in this case. But I decided to push this image to Docker Hub because if you want to follow along and you don't want to build the image locally, you can use the image that I'm already providing and providing it publicly for everyone to download. So in order to do that, I need to run two commands. The first one is docker tag. So I think that I can, here, docker tag. So basically what I need to do is I want to make sure that this image has the right name and also that includes my username, in this case, the place where I want to push this image to. I will call it customer service. I think it's customer service, maybe. Customer service, and I will use a different version, 1.0. There you go. So in this case, the only thing that I'm doing, I'm just renaming the image, the binary in this case, to have this name that includes my user where I want to push this image. And the next thing that I will do, because I'm already logged into my Docker account, is I will push this container image to Docker Hub. Of course, I want to push this. There you go. So I'm pushing this, and I already had a version, so it's already there. That's a good thing. That basically means that I don't mess it up with the name. And then the next thing that we will need to do is we will need to create, a deployment and a service so this application can run inside of our Kubernetes cluster. Because this image is public, I can use the fully qualified name inside my, deployment descriptor to point to this public image, so the cluster can download it and can use it. So let's take a look at that. In order to deploy any workload into Kubernetes, we will need some YAML files. And in this case, I will show it here because it might be easier to see that that we have here the customer service deployment definition. So this is a basic Kubernetes deployment, nothing strange, besides 3 Dapr annotations. These annotations are being used by the Dapr control plane, which is monitoring all workloads, to understand if there is any workload, any application that wants to consume the Dapr APIs. If that's the case, in this case, we are adding this annotation, so Dapr knows that there is a customer service that wants to use the Dapr APIs. And because it knows that this application wants to use it, it will bind the components to be accessible to this application. In this case, that means that our application will have access to the key value store, to the state store component, to interact with the Redis instance that we configured before. You can see we are using the image name that we just pushed. And as I don't know if you remember, but when we created the application, we provided kind of like an environment variable that will contain the name of the state store that we just created, which in this case is the same name that we're using in the cluster. Right? If you have a different name here, you can actually provide a different environment variable with a different name, and that should do the trick. And finally, we have a customer service, so we can actually send requests to the service. Right? Like we have a deployment that will create the containers, and the service will route traffic from inside the cluster to the container of this application. So the only thing that remains for us to do is just actually apply kubectl apply customer services, and that's going to basically create our workloads inside the cluster. Now we can do get pods, for example. You can see that this application is being instantiated. It will take a bit of time because it needs to fetch the image from Docker Hub into the cluster that is running locally. And as you can see also, the Dapr control plane have identified that this is the Dapr enabled application. So it's injecting the Dapr sidecar into this application in this case. That basically means that our application will be able to use the Dapr state store APIs in the same way that we're using them when we were running our application locally with test containers and the Dapr integration. This might take a little bit of time, again, because it's downloading the images and then it needs to bootstrap everything and connect everything together. But as soon as this is ready, we can actually start sending requests to the cluster to make sure that the application is running in the same way that it was running when we were running it locally. And for that, we just need to wait for a bit. You can see here that now the application is ready. That basically means that now, if we want to send requests to the application, we just need to do some port forwarding so we can send traffic inside the cluster. And for that, I have the command here. I can actually type that command because it's not that long, but just in case I don't want to introduce some typos. So there you go. So we have the kubectl command in this case, forwarding traffic to our customer service that is running inside the cluster, but exposing this into port 8080. That basically means that I can go back here to the other terminal where I have the customer JSON file, and now I can send requests to the service that is running inside the cluster. So if I do HTTP, not that one, and I send the customer, fingers crossed, there you go. We can receive, we can actually store our customer in our cluster. And the same thing as we did before, we just tested that the customer was stored correctly by just retrieving the customer by ID. And in this case, you can see we got the customer stored and we can retrieve it using the Dapr state store APIs. So in this short video, we have taken the application that was running locally using Dapr test containers, integration with Spring Boot, and push this application without changing any code inside of the application to a Kubernetes cluster that has Dapr installed. We did all the steps that we needed, like containerizing our application and then configuring our application to run inside the cluster. And then finally, we use kubectl port forward to direct traffic into the cluster and then send some requests to make sure that the state store APIs are actually working and we can store and retrieve customers. I wanted to cover this basic functionality and this small journey to Kubernetes to make sure that I can start building more complex applications on top of this and showing you different, Dapr APIs in the meantime. So thank you very much for watching, and the next video probably will be about the PubSub APIs for emitting and consuming events between different applications inside and outside Kubernetes. Thank you very much for watching.